In this tutorial, I will show you how to use Tinkercad to complete the quantitative calculations for your project. I'm going to use the ultrasonic rangefinder and the servo motor as examples, and I'm just going to illustrate on the servo motor exactly how to take the calculations. I'll be toggling between Tinkercad and additionally our project packet. This is section 3I, quantitative calculations. So you're going to need to take a calculated value, which will consist of the current and the voltage, and you'll need to use Ohm's law then to calculate the resistance of your first circuit function. And then you'll need to directly measure the value using the multimeter. So once you get on Tinkercad, you can type in multimeter and click and just drag it out to the middle of the screen here. And you can toggle here. I might just put it up at the top. So the first thing we know, or that we should know, is that the voltage that's dropped across the ultrasonic rangefinder should be 5 volts because it's pulling 5 volts and then it's being grounded. And so we can immediately come in here and we can say, okay, I know that the voltage across the ultrasonic rangefinder is 5 volts. And now we're going to look at the current, In order to find the current, we need to insert the multimeter in series and turn it into an ammeter. I'm going to get rid of this wire here. And I want to put the negative side of the multimeter into the negative rail and the positive side somewhere here where this pin is. It's a little hard to see, so actually what I'm going to do is escape out of that and just move this multimeter over a little bit. So the positive will go to this side, just exactly where we put the wire. So it actually connects and there is a flow of current through the entire circuit that we've built. Now you can see that this is set to voltage, and so I'm going to actually change it over to amperage. And now when I run the simulation, it should give me the number of milliamps. And so I'm going to put that here, 30 milliamps. All right. Now I've got those two values and I can perform a calculation for the resistance. But I also want to perform a calculation for, I also want to show how to find the resistance using this multimeter just directly on an ultrasonic rangefinder. So let me take this out. I'll reattach the ultrasonic rangefinder to the ground and bring it over here. So we have the positive terminal, we want to connect that to the VCC here. And we have the negative, we want to connect that to the ground. Now you might recognize if I click on the multimeter, we're still in we're still using this as an ammeter, and so we want to use this, we want to change this to resistance and start the simulation. Right? That gives us 167. And so the measured value is 167 ohms. So I want to first convert this milliamps to amps, and if I do that, you get 0.030 amps. And now if I complete the calculation, I have V over I equals R. And I have 5 volts over 0.3 amps, or sorry, that would be 0.03 amps. And that would give me 167 ohms. And so because these are actually theoretical measurements as well as this measured value here for the voltage and the current, they're also sort of theoretical values because they're taken on a computer simulator. You should get the exact identical value for the resistance. I actually have misplaced this. The work that I'm doing should actually be placed over here. And I'm, for some reason, having a lot of trouble highlighting this. But yes, all the work that I put over in the calculated value should go over here and work. And the equation needed, V over I equals R. And that is how you would get the resistance of circuit function 1. You'd continue with all of them. And then from there, you would determine the total resistance. The power is done in the same manner. It's just that instead of dividing V by I, you would multiply the two together. I think that's all the instructions that you will need to get started with your calculations, and I hope that this was helpful.